We appreciate you taking the time to talk about a really important subject for our industry, the future of snow sports and how climate change could be affecting it. Well, I'm Dave Tragethon. I'm the environment chair. The agenda that we have set up for today, we have Auden Schendler, who's going to deliver a pre-recorded message. He will talk about the industry and the different things that he sees that could be done to impact climate change from a ski industry situation standpoint. We have Erica Fleishman, and she's going to be joining us remotely but live. And she is with the Climate Science and Mountain Environments with Oregon State University, doing climate research and has some pretty startling projections for what could be happening with snowpacks in our mountains over the next several years. Tony Crocker is right here. He has been, he's a statistician, and then he's been analyzing snowpacks with records that go back to the 70s. And interesting information that he has that shows historically where our snowpacks have been and where they are now as well. And then Curtis Shuck, he is the founder and the Carbon Wildcat with the Well Done Foundation. Gentleman, your orange shirt right here. He's going to be talking about the Well Done Foundation and how they are actually going out there and capturing escaping methane that is 84 times more potent in warming our environment than carbon dioxide is. So the work that they're doing is impressive. And then we also have Thomas Spiglanin, and he is here representing Palm Springs Windmill Museum, and he's going to be talking about renewable energy. And what a great place to be talking about renewable energy here in Palm Springs. Let's talk about Auden and his perspective. He's a climate leader. He's been with Aspen for decades. He was their vice president of sustainability. Wasn't able to make it here today, but he wanted to give this key message for us as an organization. And you will know him because this organization has awarded the Environment Award to Auden in the past. So here's Auden Schendler. He's the author of this book, and he's going to talk to you about his perspective on climate change.
Hi there, Far West Ski Association. Auden Schendler here. I'm the author of the new book, Terrible Beauty, Reckoning with Climate Complicity and Rediscovering Our Soul. And as many of you know, because I talked to you in the past, I served as Aspen Skiing Company's sustainability guy for 26 years. Thank you for inviting me to say a few words today. And I'm going to roll right into basically a brief history of sustainable business, what went wrong, and how we can fix it. So if you go back in time, and many of you are old enough to know this, you'll remember that in the 60s in the United States, things weren't going so well from an environmental perspective, but also from a social perspective. And for the first time in American history, we really took massive steps at the legislature, at the federal level, to intervene. So think about the 60s. You had the Voting Rights Act and the Civil Rights Act addressing pressing social issues that hadn't been addressed in society. But then you also had horrible environmental degradation. Those of you who were alive then remember smog in the cities, rivers catching fire, places like the Meadowlands, beautiful wetlands that were just full of garbage. I grew up in New Jersey, and it was a dumping ground. And so the American people responded. Remember, it was the Nixon administration that did this, and they passed a suite of very, very powerful environmental laws. So in 1970, the Clean Air Act. 1972, the Clean Water Act. You also saw NEPA, the creation of the Endangered Species Act, the creation of the EPA to legislate, to enforce these different laws. These were draconian and profound. They were some of the most important laws in the history of the world environmentally. And they cleaned up the United States. If you look at LA or New York today, they look nothing like what they looked like in the 70s. And so these were profound, but they were also a big impact on business. And business noticed this. So in 1971, a guy named Lewis Powell, who would later be put on the Supreme Court, wrote a famous memo called the Powell Memorandum. And in it, he said, we can't let government do what they've done. This is out of control. We have to take this back from business. And in 1972, the Business Roundtable was created expressly to fight regulation. And you'll notice in your own industries, but also in business in general, most of the trade group job is to fight regulation. So the U.S. Chamber of Commerce, for example, which counts as its membership many of the Fortune 500 companies that say they care about climate, they have always opposed climate legislation. By the way, they've also opposed civil rights legislation. So there's been this interesting dichotomy, but what we all grew up in as the ski industry started to develop an environmental consciousness was a world where it was inappropriate or unacceptable to advocate for regulation. And instead, we believed that all of society's problems could be solved on the free market. This is the Ronald Reagan, Milton Friedman thesis that government was the problem, even though government radically changed the environment in the United States for the better. And in fact, if you poll the Clean Air and Clean Water Act, people love to eat. So as you watched sustainable business evolve, and this is true in the ski industry and beyond, everything we did was pure free market. It looked like taking care of your own house, this should be familiar to you all, reducing your carbon footprint, taking operational changes within your own arena, but not actually doing anything that would change the system. And so I began this work very enthusiastic because the thesis was that business was the only entity capable of solving climate because it was motivated by profit. After all of you know, when you change light bulbs at a resort, you save upwards of 75% on your investment. It's a massive return. So I was very, very excited about this, and I pursued this sustainable business free market thesis for the first decade of my career. But as I was doing this work, I kept asking the question, is this enough? And every time I did a project, I realized it wasn't enough because we were just one business. Others weren't doing it. We weren't actually reducing our emissions that much. If you were to cut your emissions as a ski resort or a hotel by 30%, you'd be a superhero. I mean, that's amazing. But that's not enough to solve climate. And so what I realized is that these actions were not a climate solution. They were good business, but they weren't worthy of the scale of the problem. And one day when I was riding my bike out of my office in Basalt, Colorado, down the valley from Aspen, I did a thought experiment. I said, what, if I were the fossil fuel industry, what would be the things that I would want business, which is so powerful and influential? Think about Apple and its fanatical customers, or think about your own customers. What would I want business to do to look like they were being green, to seem to be diligently working on climate and the environment, but never get in the way of the fossil fuel industry's ability to monetize the remaining reserves in the ground, which are about $33 trillion. So if I were the fossil fuel industry, what would I want the business community to do? And the answer is measure the carbon footprint, take blame for the problem, set targets for 2030 and beyond, buy carbon offsets. And essentially, what I'm describing should be familiar to you. It's the corporate sustainability plans you've all been undertaking, and we have too, and I have too. But never do anything to disrupt the system and never do anything dangerous. So my epiphany, and this is what my book is partly about, is that conventional modern environmentalism has been complicit with the status quo. And we're actually abetting the fossil fuel and plastics industry by undertaking these operational tweaks, recycling, carpooling, and so forth. That's good stuff. It's just not a systemic climate solution. So that the question you need to be asking is, what if we really cared about climate? where are our levers and where could we drive change? And I'm not going to go into great detail here because this is something that you have to get a six-pack with your best friends and think about. But the answer is that you have to think about where your power is and how to drive change at scale. And so typically that means using voice or accessing big levers like your customer base, or ensuring that your trade groups have public positions on climate and go to Washington or to state headquarters, or political headquarters, and lobby. And it's important that these trade groups have the position, not that they offer this opportunity to members, but that they take a position. That your CEOs write op-eds in a newspaper. That you change your entire utility instead of just changing your light bulb. That you get involved in elections. That you force others to join you, both in the outdoor industry and the ski industry. And if you dig in on my work, my website is audenschendler.com, and my book has great detail on how to approach these things. You'll understand this concept of power wheeling. But I'll leave you with the note that much of what the ski industry has done historically has been to focus on itself, to take blame for a problem, in other words, that we operate in a fossil fuel economy, but take blame for something that we didn't create and didn't ask for. We asked for cheap power, we didn't ask for power that would destroy our industry. And so this is a cool opportunity where the snow sports industry actually has enormous amounts of power. It is widely respected. Like the insurance industry, it's on the front lines of the climate movement. And it should lead. And the dirty truth is we haven't led to the extent we can, but now is the time and we have the potential to do it. And by the way, at this moment in American history, the ski industry can also lead on basic democracy. So for example, Congress electing where money goes, or due process for citizens, or immigration reform, all these things that matter today, our industry can be more vocal and more powerful. Anyway, thank you so much for listening to me. I hope you have a great conference. I think fondly on my last visit to see you guys, where I think it took place at the Pepper Mill in Reno. I miss you. I wish you the best of luck. As you may know, I'm retiring from my job and I'll be working on climate in different capacities. So I look forward to seeing you on the hill, on the slopes, and in the field. Thanks, Dan.
That's Auden Schendler. I think that's a great keynote for all of us. And I look forward to sharing that with a lot of my friends in the ski industry. You know, let's take a look at this from a scientific context. One of my thoughts on the importance of this particular session was when I saw an article in the Oregonian that said that the latest climate study in the state of Oregon forecast a 50% reduction in snowpack in Oregon by 2100, the end of the century. So I reached out and contacted the director of the Oregon Climate Research Institute that publishes that. And Erica, I think I see you there, and your mic is muted, but Erica can't join us here. You're in some research area right now, aren't you, Erica?
No, I'm in Corvallis, Oregon today.
In Corvallis, where the temperature is going to reach a balmy 72 degrees. And here in Palm Springs, it's going to reach 105. But maybe, Erica, you can take us through the study and talk about some of the implications on what you found and how that could be affecting skiing and snowboarding in the future.
Sure, I'm happy to do that. Thank you for the invitation. At some point, you all will have to explain to me why a ski group is meeting in Palm Springs in June, other than economics. I'm baffled by that. Anyhow, thank you again. If you could advance to the first slide, that would be great. I, as Joseph mentioned, am director of the Oregon Climate Change Research Institute. I'm also a professor at Oregon State University. The Oregon Climate Change Research Institute was established by the people of Oregon via the state legislature a little bit more than 15 years ago. We have a number of charges in our enabling legislation. One of those is to facilitate research on climate change by public universities within Oregon. And so that's physical science, biological science, social science, all the types of science that relate to climate change. We provide technical support to state and local government on topics related to climate change and climate adaptation. We interact with the public quite a bit, just like I'm doing today. We're also the administrative home of the Oregon Climate Service, which is the office of the state climatologist of Oregon. So basically the state climate office. And we in turn, OCRI, we are hosted by Oregon State University. So that basically means we're OSU employees, but we're not a wholly owned subsidiary of OSU. Our charge is really to be assisting the state of Oregon as a whole. Next, please. And we deal a lot with adaptation because although we all would like to be mitigating climate change, there's only so much that Oregon can do, although Oregon has quite strong policies related to mitigation, but we're all kind of stuck with it. And so we do a fair bit of work on adaptation in addition. Next, please. And so given the focus on skiing, I thought I would talk a bit about changes in the snowpack. And what has been happening and what we expect to happen over the next 50 to 100 years. And because there's only so much we can discuss in about 15 minutes, I want to talk a bit about drought. The simplest definition of drought is just insufficient water to meet the needs of what people want to do with the water. Some definitions focus on physical metrics, so the water balance, the atmosphere, the soils, precipitation supply and demand. There are definitions of drought that relate to different time periods. There are definitions of drought that relate to effects. So for example, effects on agricultural systems or social systems. Regardless of the drought metric, drought across the Western United States is becoming more frequent, it's becoming longer, and it's becoming more severe. Next, please. People who study climate and drought have identified a particular type of drought called snow drought. And snow drought refers to abnormally low snowpack on a given date. What do we mean by normal? In climate world, people usually refer to normal as an average over the most recent 30-year period. So when I say normal, it's not saying that there is a universal normal, but it's referring to those 30 years. There can be two types of snow drought. There can be dry snow drought and warm snow drought. Dry snow drought is when you receive fairly little snow during the snow season. Warm snow drought means that temperature was high. And so generally speaking, the amount of precipitation was roughly normal or could have been above normal. But because it was warm, either it melted early or more of it came as rain than as snow. So both of those conditions can create low snowpack relative to a recent historic period on a particular date. And next slide, please. If we look at this rough area, so I just bounded this area so we could look at some summary data over the past roughly 30 years or so. Next, please. Thank you. The October to September is the water year. And so if we look over the past 40 years at cumulative precipitation over the water year, each of the water years across the Western United States, what you'll see, first of all, is a whole lot of variability. And so you'll see a number of years above normal, a bunch of years below normal. The red and the blue, hopefully if anyone is colorblind, you know that there's some stuff below the normal line there. And you also see a slight decreasing trend, but that trend is actually not statistically significant. There's a tremendous amount of variation in the precipitation system, more so than in the temperature system. Next, please. If you then look at the 5-year running drought trend over that same period of time with one of the many indices that are used to measure drought and looking over a window, what you'll see is less variability in the drought index than in the precipitation index. And this trend over time is statistically significant. So you see a lot of variability in precipitation, but you're still seeing a trend toward drought. Why is that the case? A lot of that relates to temperature increases. So next, please. Again, across that same geographic area and that same period of time, if, for example, you look at, well, temperature is increasing throughout the year across the Western United States. If you look at temperatures, minimum temperatures in January, those are increasing, and that's statistically meaningful. Next. If you look at the first freeze day, so roughly the first day that snow can fall, That is increasing steeply over time. So it's getting cold later in the year every year. On average. And then if you look at the last freezing day in spring, basically spring is coming earlier. So none of these are particularly surprising if you've been paying attention either to information or just to paying attention to what clothes you're wearing on a particular day where you live. But all of this means that less snow is materializing. Even if we're getting a normal amount of precipitation, we're getting less snow. And the elevation of the snow to rain transition is going higher. And so roughly at lower elevations where we used to get a fair bit of snow, over time we're getting more rain. And so we're still getting snow at high elevations, but it's really only at the highest elevations. Next, please. Now I'm switching more to Oregon because this is where we have some more detailed data. There's a lot going on here. If we look at the left side of this graph where there's a gray background, what you're seeing there is what's been observed. So you can see again a lot of variability over time. If you're looking at the right side, what you're seeing are the projections out to the end of the century. And I want you to notice two things. One is that there's still a tremendous amount of variability. So you see these really broad bands. And that indicates that different global climate models that have been downscaled, if you're familiar with that word, basically they've been made relevant to a much more, to a smaller region, that there's still a tremendous amount of variability among models and even within models, but still a slight increase over time. So precipitation across much of the Western United States is expected to stay stable or even increase a little bit. But if you go to the next slide, temperature is increasing a lot. So again, even with a fairly high amount of precipitation, we're getting more, on average, we're getting a higher proportion of that precipitation coming as rain than as snow. And with temperatures increasing, that snow is disappearing more rapidly. What you'll also see here is a pretty steep increase in projected temperature. This is annual, and you'll see less uncertainty than you did with precipitation. What these letters SSPs mean, that's more or less, that's scenarios of global greenhouse gas emissions, where the warmer colors indicate higher levels of emissions. If you go to the next figure, these are Oregon's level 3 ecoregions. Ecoregions are basically areas with similar climate and therefore similar vegetation. So you can think of them as sort of climate zones. And obviously the most meaningful for snow are the Cascades and the East Cascade slopes. So those green areas that are more or less vertical in the middle of your diagram. Where I live, the Willamette Valley is to the left. Next, please. Thank you. And so what I want you to see here is the reduction in the snow to rain ratio. So this is not total amount of precipitation. This is how much of that precipitation is coming as snow versus rain in the future. And if you look at the left, what you'll see on the East Cascade slopes is a pretty sharp decrease, about 50% less precipitation coming as snow than we're going to get about 50% less snow. So we'll still get precipitation, but in the mountains coming much more as rain than as snow. If you then look in the Willamette Valley, we don't get that much snow in the first place, but you'll see these same types of trends regardless of topography. But again, most meaningful for snow and the snow industry in the mountains. And next slide, how this manifests, this is a projected change in drought. Some of the fancy stuff, this CO2 aware Penman-Monteith, that's a reference to the fact that these particular projections take into account the response of plants to increases in carbon dioxide concentrations. Happy to talk about that later on if you like. The wetter color, or the cooler colors actually indicate some areas of the state where there may be higher water availability in the future. But again, much of the state, including the areas where we get most of our snow in the Cascade Range, are likely to become much drier over time. So again, even with more precipitation, less of it falling as snow and higher temperatures resulting in lower water availability. This year is a really nice example of this type of situation across the Western United States. So what you see on the left is this is snow water equivalent. So basically how much water is contained in the snowpack. So at the peak of this past snow season, we were doing pretty well across much of the Western United States. Arizona and New Mexico were pretty dry throughout the year. Some of the Southern Rockies were pretty dry, but across a lot of the Sierra Nevada, the Cascade Range, much of the Rockies up into Idaho and Montana, there was plenty of snow. Then you look on the right and you see all the warm colors. The snow melted really early across the Western United States. So basically it was hot. And so April and May were fairly hot everywhere and they were fairly dry. So as a result, even though we had a pretty good snow season, right now we're going into drought. And that may be somewhat less relevant to the ski industry as a whole, but if you think about just water supply in the future or water supply for making snow when temperatures are cold enough, this is what the future holds for us. Next, please. That figure I just showed you and one more that I'm going to show you, they were produced by the National Integrated Drought Information System. We work very closely with NIDIS. They, under the best of times, have been understaffed and staffed by intelligent, caring, terrific people. They are at risk with some of the projected budget changes that the federal government is considering. If you like what they do, I encourage you to make your thoughts known and as an industry to speak with a unified voice on that. Next, please. One of the products that you can look at on NIDIS's website is what's happening with current drought status at ski resorts across the Western United States. So, so this isn't saying, yes, it is June, and so I recognize that it's June and there's not much snow anywhere, but this is just indicating if you look at overall drought in the areas where the ski resorts are located, many of them right now are starting to become fairly dry, again, especially in the southern portions of the West. So again, this is not related to season. This is related to water supply and demand on the whole. It's going to be a dry summer, and there's likely going to be a higher wildfire risk this summer. Next, please. So, you know, what I want to encourage people, you are out there. And so, you know, computing power is increasing and data supply is increasing. Those things are terrific. And bringing that together with people's experience, what they value from these systems, what they know from their personal experience, from the things they care about, bringing those things together is really important. It's really important politically. It's really important to a lot of us personally to be able to just get out there, to take a look, to enjoy these places. And so I just want to end with the importance of that. And if you will flip to the last slide, please. Sorry, I can't be with you, but I hope you get a chance to get up to some of the higher elevations where maybe there's still a tiny bit of snow, and enjoy your time in the desert. Thank you again.
Perfect. Thank you so much. That is like a 700-page report that she just brought down in 15 minutes. So that alone deserves another round of applause. Thank you so much. Now we have an historical snowfall statistician with bestsnow.net, Tony Crocker. He's right here. When I was the marketing guy at Mountain Meadows, I used to talk to Tony usually once a year and give him all the information about the Mountain Meadows snowpack. But he's been doing this going back to data that's as early as 1968, I think. So here's Tony to talk about what's happening with mountain snowpacks historically and maybe a look ahead.
After that last presentation, I'm certainly correcting your terminology from snowpack to snowfall. Is everybody hearing me here?
Yeah.
Okay. I've been collecting snowfall data from North American ski areas since '92, with data going back as far as the late '60s. Summary data for 116 locations are on my website, bestsnow.net. And I have at least 80 every year since 1989, at least 60 since 1982, at least 30 since 1973. The chart you see there weights equally 8 ski regions, 7 in the west and 1 in the east. 7 western ski regions have similar lift surf ski acreage, and the areas with data cover about 90% of both ski acreage and skier visits. Some people began inquiring about ski area snowfall trends in the late 2000s. And at that time, my data going back to the early 70s showed no trend on either an overall or regional basis. In 2001 to 13, worldwide temperatures increased at only about 1/4 the rate predicted by the climate models. Temperatures increased sharply from 2014 to 2016, and also in the past 2 or 3 years. So the overall long-term trend now is very much in line with the climate models, projecting near-term increases about 0.2 centigrade per decade. While there's strong scientific consensus about rising temperatures since 1970, and those increases will continue, there is very little consensus that climate models can accurately predict clouds, precipitation, or regional climate nuances. Therefore, I continue to examine snowfall data each season. In this chart, this first chart, there's still scant evidence of any decline in snowfall overall at North American ski areas. Why hasn't it been? Yeah. Okay. This is a bunch of numbers. These are the areas which happen to have unusually complete data for generally 50 years plus. The point here is not to go through all these numbers, but to compare the seasons after 2000 with those before. And those highlighted numbers at the bottom are the average and standard deviation. So, those particular areas, about 5% less snowfall in the recent seasons. But the other point is that standard deviation is also down by at least as much. So, one of the things you often hear is about so-called climate whiplash, greater variability. I insist quite firmly that in terms of ski area snowfall, that is a myth. So with precipitation not necessarily affected by rising temperatures, and their arguments, as we just saw, we can increase, the focus of study should be on whether and where there might be more rain and less snow. In interior regions of Western North America, rain is sufficiently rare that any impact upon snowfall lies decades in the future. One could argue that the Colorado Rockies, with their high altitude resort elevations, are more insulated from climate change than any other ski region in the world. So I narrowed my focus to the ski regions that have always experienced significant rain, those being the Northeast and lower elevations along the West Coast. This is here's the Northwest since 1971. The early 70s had a concentration of strong La Nina years, which produced 5 banner years that you can see in that chart. And the bad one there in 73, by the way, was a strong El Nino. So these that trend line is really very modest, and I would contend that it's the beginning that's the climate main driver of it. It's hard to get data farther back than that, but this is an interesting one. This is an Utah Department of Transportation measurements at the base of Alta ski area. And if you started that trend line in 1970 or 1980 and ended it in 2022, it wouldn't look very good. But Utah had a record season in 2023, as many of you know. And if you go back there, you see that there's a period in the 50s and early 60s that was almost as dry as the one we had more recently. The 1% increase in temperature is out of basic physics, translates to an increase in rain snow line of about 500 feet. It's obviously not simple because that rain snow line varies by season and by storm. It's also the other points. 1 degree temperature increase since 1970 is a worldwide average and is different in different climate zones. It's well known to be far larger in mostly the Arctic, for example, which we've also known about. Even within a location, it varies seasonally. It's known to be as much as 2 degrees centigrade in continental climates in the summer specifically, and that explains why the alpine glaciers in both Europe and North America are retreating, even though their snowfall may not be declining at all. Oops. So this is California. It's a flat trend, but you can see that we're the most volatile ski region in North America by lots of good years and lots of really bad ones. What we really would like is to have a precise split out of every storm daily, how much is rain is, how much is snow. The Central Sierra Snow Lab did this for 31 years. And here, you look at the end of that table from 2013 to 2018, and you see a more consistent trend of more rain and less snow during that particular period. Unfortunately, that no longer calculates that their numbers went away. So I have to go back to, so for any further analysis, all we can analyze is total water to total snow. And in the Pacific states, you know, Mammoth, which is essentially all snow, is 13%, so 13% water. But once you start going over 15%, you can imply that there's more rain, and in particular once you get over 20. So here's Alpine Meadows. This is similar elevation as the Sierra Snow Lab. You know, absolutely the same climate zone. And you see that big spike there in 2015, and the same trend of wet years from 2013 to 2018. I also add that 13 to 15 were drought years, so you have low snow and a high proportion of rain. You know, everybody remembers those were pretty ugly seasons. However, we now have more data, and you look at 2019 through 2023, and the numbers kind of go back to look like what they did a while ago. So, you know, the message is snowfall's really volatile, and you need to look at the long term. So now, fortunately, Oregon is an interesting place, because now you have locations that are much more marginal with respect to the rain snow line and government camp. The base of Mount Hood, a little under 4,000 feet, is you know, in the data, in the long-term data that you file, this is one that there's a lot of data, and it absolutely shows the trend is not going in the right direction. Even at the beginning, 25% water percentage means you're getting a lot of rain, and you know, that line average is now towards 35. So you know, that's a problem. However, the ski areas, Hood Meadows is measuring site is 1,500 feet higher than government camp, and Hood Meadows gets 450 inches a year compared to 250 at government camp. I guess I should concede that there's another area, Mount Hood Ski Ball, that is right near government camp, and you know, it does have a reputation for nice terrain, but unreliability due to, you know, a little more rain than you would like. So now, staying within Oregon, here's Crater Lake. You know, this is a very slow trend line. It's still under 15% now. It's pretty safe to say that from November to April, you know, most of their precipitation is snow. You see that ugly year there in 2015 of the entire West Coast. You saw it in the California numbers, and that applied all the way up to Washington State and Whistler as well. But what goes away from this is we have a whole bunch of specific ski areas, Mammoth, Bachelor, Mount Rose, Kirkwood, the Whistler Alpine, that are higher than this in a regional context, and you know, rain is just a non-issue for these places. And you know, that goes to my personal experience skiing in Mammoth for the last 45 years. So now here's one. This is actually the curve that scares me most. Alyeska has measuring stations at the top of lift service and in the middle, and it's known at the bottom at 250 feet elevation. It's quite a bit of rain, and you know, now we're seeing mid-elevation rain. Those 5 years from 2014 to 19 were all worse than any of the previous 32. Since 2019, we've gone back to, you know, a few more years in line, but the current year at 50%. And I actually heard this during the season. You know, they were reporting 700 inches up top, but I heard there was a lot of rain and the skiing wasn't that great some of the time. this is the Northeast. You know, you can see a little bit of declining trend in there. You know, they also have some years back there in the early 70s. And in the Northeast, it's not altitude. It's in the West, it's very clear-cut altitude is the issue. In the Northeast, latitude and distance from the Atlantic Ocean factors are probably more important. Here's one location. Pinkham Notch, actually, it's the pass between Tuckerman's Ravine and Wildcat Ski Area, New Hampshire. You know, pretty representative of Upper New England, I think, in terms of overall climatology. You know, the average is over 20%. Northeast skiers just get a lot of rain. And if you look at those little numbers at the top, you see that November and April is 45%. You know, basically these places get more rain than snow in November and April. And, you know, that's a big challenge. So, and it's not quite obvious now, but the 2016 in the Northeast was a year very much like 2015 on the West Coast, with really extreme amount of rain, not a lot of snow, extremely bad ski season. And these outlier events that, you know, might be 1 in 50-year events, you know, we can probably expect them to end up being more like 1 in 20 or something like that. So here we are in Southern California, so where I've lived and skied since 1976, so I thought I should address that. This is not my graph, it's a better one than mine, so it's easier to read. And you know, LA rainfall since 1878 is, you know, super volatile, but there's not an upward or downward trend. And I've noted the period there, 1944 to 1964. 10 of those years had less than 10 inches of rain in downtown LA. And that would translate to about 75 inches in our local mountains. These were not the good old days of skiing. There also wasn't too much snowmaking back then. So now here is this snowfall is my estimate based on ski resorts, because Southern California areas, you know, haven't measured their snowfall very long, and there's some question about how accurately they do it. You know, that's a rather mild downhill trend. The other thing I've done by seat of the pants is actually count the days for these ski reports that I think it's raining in the ski areas. And, you know, I'm not going to ascribe statistical significance to this, but, you know, it certainly is not what you want to see. And, you know, my gut feeling is that, you know, this is real, and these mountains are downwind from an urban heat island with 15 million people in it, and I just suspect that's not good for our local mountains. Now, I'm generally skeptical of weather models can project changes in weather patterns. One of those predictions is that latitudes in the lower 30s may become drier. So in fairness, here's Taos, New Mexico's snowfall since 1973. And you know, that's a pretty bad looking trend. The record high here was the first year of the data set. And the season we just completed was their second worst. And those do influence the shape of that curve. And then the other part of why it's hard to know whether that means something is because you see the LA numbers, you know, similar, actually lower latitude, no trend. I have numbers for Arizona snowfall, and you know, it's a shorter period of time, only about 25 years, but there's no trend in Arizona snowfalls. So I don't really. You have, when you look at numbers, you also have to have a meteorological explanation, and you know, I don't if somebody can say why New Mexico is getting drier and Arizona and Southern California aren't, you know, I'd be interested in hearing about that. So here, this is Portillo, Chile. It's the actual data is from 1970 to 2007, but there's another data set from a mining site that goes back farther. And the drought in Chile makes the one that we have in the American Southwest look like child's play. You can see a bunch of years there since 2010 where you're barely getting half the normal snowfall. And you know that's pretty extreme. And but the interesting thing is if you push that data way back, you look in the 1950s, and there's another pretty bad period in there. That line is, yeah. So oddly enough, there's no trend line. That is a mixed set of data. So you know, there might be people who would dispute the science. But it's interesting in that case, as with the Alta snowfall and the LA rain, you do see this same period in the 50s and 60s that was very dry and was not very good for skiing. In conclusion, you know, I'm talking about snowfall, and that's what matters to skiers, and that's what this audience is. You know, the hydrology is a different subject. You have evaporation from warm temperatures. You have problems with the water supply that our previous speaker explained very well. But there is a narrative in the mainstream media that skiing is a doomed industry. And in the case of the Western United States, I push back against this strongly. Our children and grandchildren are going to be enjoying these same ski areas with overall not very different conditions than we've been skiing during our lifetimes.
Who agrees? Tony, thank you so much. And we are going to hold you to that. But the news is kind of sobering. Even some of the slides that you showed, it's somewhat sobering. It's got our attention, especially we're talking about our kids and our grandkids. What are we going to do about that? Well, I'm glad that we are joined today by Curtis Shuck. He is the founder of the Well Done Foundation. Stacy, his wife, is here as well. And as we all know, Curtis probably wouldn't be able to do all the things that he does without great support from someone like Stacy. So I'm going to turn the mic over to Curtis, and then I'm going to queue up your slides.
Awesome, thanks, Dave. Maybe this one will work.
Yeah,
You guys
that'll
hear
work.
me all right?
You just get it closer.
Shouldn't be too much of a problem here. Awesome. Well, gosh, it sure is great to see everyone. Just by way of full disclosure, so I am a recovering ski coach. Sorry. So I've been involved in alpine skiing since the 1970s. I actually grew up in Anchorage, Alaska, and skied at Alyeska, and that's where I took my first paid coaching gig, which took ski bumming to a whole new level. I was able to continue to passionately pursue that for 36 additional years. I actually met Dave and worked with Dave at Mountain Meadows when I led the program there for the Alpine program. And had an interesting turn of events for myself personally take place in 2019. Now, at that time, I was coaching in Red Lodge, Montana, the program director there, and some of the coldest skiing conditions, that certainly even being from Alaska that I've been exposed to. They call that place Rock Dodge for a very good reason. If you've ever skied there, beautiful spot. Doesn't get a lot of snow, and that little bit that does there usually tends to blow to North Dakota. But during that summer of 2019, I came across my first orphan well. And up until that time, I had no idea that orphan wells were even a thing or even a problem until I was out in the plains of northern Montana, just about 60 miles east of Whitefish, Montana, in the east slope of the Rockies, and came across my first orphan well and just couldn't believe my eyes. And having spent time in the oil and gas industry and various roles and responsibilities to pay for my skiing problem, I was able then to dig deeper into that issue. And that was July 25th of 2019. I was out touring, saw a bunch of wheat fields with some farmers who we were working on getting their grain to the Pacific ports. And by the time I got back to Bozeman, Montana that night where I live, We actually had secured the domain names for the Well Done Foundation, registered the organization with the Secretary of State, and had absolutely no idea what we were doing, but just that somebody needed to do something. Go to the next slide there. So this is a dirty business, as you can see from that particular slide. That's actually a well that we were working on in New Mexico. But as we were learning more about this is again 2019, long before orphan wells were cool, and we call that everybody's dirty little secret. When I started to talk to the industry, the oil and gas industry, the producers, they didn't want to talk about it. When I started to talk to the regulatory agencies, they certainly didn't want to talk about it. And so what we had is this conundrum of finger pointing and name calling of whose fault it was and who should be responsible. From the beginning of my journey and our journey with the Well Done Foundation, we have never felt that it was ever a taxpayer issue. Now, certainly there's been some tax-paying money that's been contributed to that, thankfully, over the last administration. But really just the down payment to manage this huge problem, which, by the way, exceeds 3 million orphan wells across the U.S. And many of those wells that have been identified in that list are not a fixed number. So in other words, the wells that we've identified today are subject to change because as operators continue to struggle, just like anything in infrastructure, it's got a period of time, a useful life or a production life. Those wells, if they're not maintained, then they start to fall off, their production falls off, and they become what's called a marginal well. Well, the longer a well is marginal, the higher it costs to maintain it and to produce it. And so pretty soon you've got just this huge number of wells that are coming into this work stage. And so what's important about that and why that's significant is that when we formed our organization in 2019, we had no idea of the scope of the problem that we were up against and the fact that we would meet with so much resistance again from both the regulatory side and the operator side. Now, interestingly enough, as we started to shine a light on this dirty little secret, right away we felt that it wasn't enough for us to just learn about this and talk about the issue, but we really needed to do something about it. So the Well Done Foundation, we're actually plugging our 60th well right now across the US. We operate in 15 different states today with various groups of volunteers and paid staff. And what we tell people is that we're in the get shit done business, right? Yeah. So we like to talk about and bring light to the subject and talk about just the amazing work that our organization does. But we also like to go out and show that we can get the work done. And so we certainly, I think, have demonstrated that. If you go to the next slide. So this is kind of our view of the world here, right? And so for our work, it doesn't really matter where you live on the climate change spectrum there, right? Whether you're a climate crusader or a climate denier, doesn't matter whether you're a Republican or a Democrat or a Protestant or a Catholic. What matters is really about doing the right thing and leaving things better than we found them for our future generations. And that, I think, is at the core of the Well Done Foundation mission as we're moving ahead, is to continue to stay focused on how do we do better today than we did yesterday. And what's exciting about this is that I do think that from pressure that you heard Auden talk a little bit about earlier, that the regulatory and the legislative bodies have figured out the fact that maybe we need to do something. Now, question is too little, too late, where does that all fit in the spectrum? But it's not hard for me as I'm out visiting thousands of well sites a year to understand kind of how we got here, right? And what's exciting to see is that there is a change regulatorily now moving forward. So now the oil and gas industry is one of the most regulated industries in the world. And so we have taken, I think, some really important steps to turn the ship. The problem is we're left with all of these legacy assets that are out there and that we're dealing with. We do a lot of work in the state of California. We've got an agreement in place with the county of Santa Barbara, where we're doing work out there for them, measuring orphan wells. We've worked with CalGEM, who is one of the regulatory agencies here in the state of California. We've been measuring wells and helping to plug wells up in the Bakersfield, Kern County area. We're working now with LA County on a special project out there. As their sustainability office is looking at how to address this huge unfunded mandate. And one of the things, we advance to the next slide, that's really important is to have a visual here of kind of what this looks like. I mentioned it's a dirty business. And for us in the ski industry, it's typically a clean industry. We like to think about, just what this beautiful, pristine environment we are. And then here's the Well Done Foundation out there getting dirty all day long. That slide on the left, you see, that's an optical gas imagery camera that is recording the methane emissions from that well. The picture on the right is that open well bore. This is one of the first wells I came upon up in northern Montana that I just couldn't believe my eyes. You can see on that picture on the right, there's actually a dead bird sitting next to that well. That well has elevated levels not only of methane, but of hydrogen sulfide, a dangerous and deadly gas. And interestingly enough, for scope, that well, just that well alone, emits about 1,392 tons of CO2 each and every year, which is equal to about 350 automobiles. And you would need to plant 43,000 trees just to be able to offset the impact of that one well, right? And those 43,000 trees would take about 420 acres to support them. And so as we started into this work, it became very evident that this was very impactful, that each one of these projects is a huge victory, right, in the grand scheme of things. And so it made, I think, our job much easier in terms of just how do we manage this whole climate change issue, because it's so overwhelming, right? Some people feel, many of the young people today feel like, screw it, right? What can I do that's really going to make a difference? Well, I think we've proven here on our one well at a time approach that this really is meaningful and that these projects do yield results. And what's exciting is that these results are immediate. In this fast-paced world which we live, data-driven every day, it's really hard to get people focused on a long-term program. And that's why we love this instant gratification of this orphan well plugging program. Go to the next slide. Go ahead and advance, Dave, if you would. So this is me at one of our ski areas up in Montana, a little place called Teton Pass. We love mom and pop ski areas, grew up, working at those all across the country. And what's important here is you see this is one of our vehicles that's out there taking a break from the road trip to go make a few turns. In the back of that truck is Dorothy. If you've ever seen the movie Twister, that maybe fits in, but that's one of the devices that we use to help measure methane on these open well bores. Go to the next slide. This is some of the orphan wells that we encounter all across the country. They're in people's front yards and backyards, so they're not all out in the middle of a wheat field. These are impacting people's daily lives. Next slide, if you would. This is a well that we just completed in Erie. In fact, I was just with the team last week before I got back to Oklahoma. Right in these folks' front yards, literally 15 feet away from the neighbor's front door. Next slide, if you would. So one of the things that we're hyper focused on is working with communities and with organizations. This is actually with the Montana State, University of Montana in Missoula, and where we've actually embarked on a special carbon offset program with them to help plug wells to offset their commuter program, which is a very exciting opportunity, and one I think that lines up well with some of the discussion that's happening in the ski industry in terms of how do we get people aware of the problem. How do we actually take some meaningful action kind of get away from that bare minimum business model that Auden spoke a little bit about today, where ski areas, as well as every other industry, talks about, well, we just want to do just enough, right? Because it's expensive. And hey, look, there's no doubt about it. But for the ski industry, there is an existential threat of global warming, of just the impact of these changes, and what it could mean into the future. So this notion of virtue signaling, which is kind of just waving the flag, right, if you would, or we call it green waving, is how do we actually take some meaningful action at scale and in a way that is affordable and really delivers results. Go to the next slide, if you would. So what we've done is we've really focused on our ability to get out in front and tell this story, how important it is. So in 2023, we started working with the Smithsonian Channel on a special project called How Did They Fix That? And so we spent a couple of weeks on the road with these guys and several of different states working on our various projects to be able to communicate this problem and really talk about what the solutions are. This is just a shot here that I used with the Society of Environmental Journalists about a month ago in Phoenix to talk about the coverage that this amazing project that we're involved in has received, and more to come. And in fact, I just was talking with someone today who saw one of our articles in the Reader's Digest of all places, right? So far and wide, we've got some pretty amazing coverage. So what we've done through our efforts is we have a number of various campaigns that we've embarked on. One I'd share with you today, and there's plenty of stickers here, I hope, for everyone, which is our Plug the Baby Plug campaign. Might have heard of Drill Baby Drill. Well, if you're gonna drill baby drill, you still need the plug baby plug, right? So that's one of the important programs. But also in looking at the folks that follow us around the country. So one of the great opportunities here with the Far West Ski Association is just through that information. Dave will be working with us on talking about some of the area operators about a commuter offset program. So visitors that, keep the ski areas alive and make their way up and down the mountain every week in their automobiles. There's great ways to offset that using our University of Montana model. And then just following along on the work that we do. We're pretty active on social media. We got a lot of great projects going on all across the country. And we are just so appreciative to be able to be here with you all in Palm Springs of all places. To talk about this amazing work, and I think hopefully, deliver this message of hope, right? That there are people out there doing things, and that the things that are being done actually do matter and do deliver results. And for me, that was especially meaningful as I saw just yesterday through the news that the first ever heat advisory had been issued in Fairbanks, Alaska. And so the first ever, right? So I think that for me, that just brings home the fact of how important our work is to continue to support this important industry. So thanks, folks.
Our next panelist is also going to help us determine what it is that we can do.
Sounds good. Hello, everybody. I do give tours at the wind farm up here. But that's not what I'm going to be doing today. At the wind farm, I interpret what wind energy can do and how the wind is used to make electricity. We do actually make electricity. I did use this photo on purpose because it does show Mount San Gorgonio beautifully there in the background with all of our wind farms in the foreground and the nice yellow wildflowers. We had a nice bloom 2 years ago, a whole lot of rainfall, and then, as you can see, a pretty good snow year too. But they are machines that actually make electricity that goes directly to your homes. So if they are spinning, they're making electricity and it goes, literally, it's used by your homes as you are using it. It's not necessarily stored. We'll talk a little bit about that. But they are producing electricity. There's a generator inside, the wind blows the blades around and the electricity flows. We have in the San Gorgonio Pass only about 650 little wind turbines. It's really a small wind farm. Across the state of California, we make 7.7% of our electricity from wind. So that's a nice renewable source. It's a good thing to claim. We also make about 19% of our electricity from the sun, and add to another 9% from hydroelectric sources. So when you add all that up, you get to a fair amount of renewable energy. On top of that, another clean source, we still have a nuclear power plant operating in California. We make the difference up, though, with natural gas, and natural gas is putting out carbon dioxide. So the state of California is planning to undo that as best they can. Their goal is to do that by 2045. So they push the can a bit farther, kick the can a little bit farther down the road, but you got to do that. There's a whole lot of planning that goes into making this happen. One of which is storing energy, and we'll mention that in a minute. But we are sitting on, for the most part, these things are sitting on private and public lands. They are not government owned necessarily. The wind turbines themselves are all private. Throughout the state of California, we make our electricity 100% except for nuclear by private companies. So the Southern California Edison, Pacific Gas and Electric, San Diego Gas and Electric, all divested themselves of their production assets, with the exception of the nuclear power plants, which still remain their responsibility. But they are regulated by the different entities around, and basically this area alone provides enough power for 10 times the city of Palm Springs every year. So it's making a difference. It's a real thing. It's a real industry. So people who say otherwise just don't understand that these are companies investing in this to make money. They're not in this to lose money. So we do power about a third of Riverside County. So it's a fair amount of power. Locally, we get a lot of bad reputation about how all of our power is getting sent to LA. Well, guess what? LA needs a whole lot of power. We're making more power than this area can use. So yeah, our excess energy does go to LA. We've also got massive natural gas plants here that can outproduce the wind farms. So keep that in mind too. When LA needs power, that's what they turn on. It's not like in, Christmas Vacation, where they had to call on the auxiliary nuclear plant because Clark Griswold's lights finally came on. It's not kind of like that, but they do part of the. Here we go with that clicker thing again.
We go.
Just like that. There we go.
There it is.
So throughout the state of California, we don't have a whole lot of wind farms. Why is that? California is not a very windy state. We're known for sunshine. We may not be the sunshine state that goes to Florida, but we're known for sunshine. So we've got lots of resorts. We've got lots of sunny places. We have a whole lot of solar farms out here, but we don't have a lot of wind. The only place we get wind is in our mountain passes. So as it happens, one of the nicest passes in this area is the San Gorgonio Pass. So it's Mount San Gorgonio to the north, it's Mount San Jacinto to the south, this beautiful mountain set behind us. And that creates a funnel for the cool air from LA to come flowing through into the hot desert. So the air in the desert is less dense. The air out toward the ocean is much more dense, so it creates a natural onshore flow. You get these two big mountains and they create a funnel, basically. And so NASA calls this the most consistently windy place in the United States. But we're not windy in general. If you want to see the wind resource, you're going to start down in South Texas and you're going to go all up into eastern Montana. That's the wind resource in the country. But we do have another wind farm. Go back just one real quick. So up there, the biggest wind farm is in the Tehachapi area. I actually visited that about 3 weeks ago. Took a nice little hike, the wildflowers along the Pacific Crest Trail, and walked along the turbines. They've got a lot. I've never seen so many in my entire life. But we are about 7% of California's electricity. And as I mentioned, that we are only windy because we have the funnel, so to speak, and all of those areas that you saw in California are set up the same way, with the exception of the Altamont Pass, which is east of San Francisco. That actually is also, you get the air brought in because of the Sacramento Delta. So the air will just blow in from that. So in general, across the state of California, we make our electricity from a number of different sources. Many of them are clean, not all of them are clean. The nuclear plant does not put out carbon dioxide emissions, so we consider that a clean source. The natural gas plant does put out a fair amount of carbon dioxide in operation. There is carbon sequestration coming along that is going to hopefully capture some of that. But in the long run, all you're doing is capturing it, putting it in the ground and hiding it somewhere and hoping it doesn't come out. Hydroelectricity, believe it or not, California is second in the country in hydroelectricity production. So we do produce a whole lot of electricity from dams. Because we do have drought conditions a lot of times, we don't count that as renewable, believe it or not, but it is a renewable source. It does not put out carbon dioxide emissions. In addition to the dams across the state, they tend to drop their production in the middle of the day. And the reason is because we've got a whole lot of this stuff. We've got a whole lot of solar panels. And so since we're making electricity in the middle of the day, they decide, well, let's just hold off releasing the water out of the dams until we need it. When the peak demand time comes, when we all go home, we turn on our air conditioning, the businesses are still open, and we've reached the maximum demand, the same time the sun sets. So it's a massive challenge for the state to make up for that. The state of California is doing a remarkable job of keeping their energy reliable. We haven't had brownouts or blackouts in this area for a couple of years now. So they're doing pretty good. We actually have a tremendous geothermal resource as well, which many people don't know about. Down south of the Salton Sea and up north by Calistoga, we have some geothermal plants that basically drill down into dormant volcanoes, and hot brine comes up. That hot brine is flashed into steam, drives steam turbines, makes electricity. It's great, but you don't have a whole lot of places in the world that you can get that. We are very blessed in California to have two of that, so we do lead the country in geothermal production. And when it comes to wind, we are not even in the top 20. Not even in the top 20. We led the nation in the 1980s with our incentives to bring the wind power into California. But in general, we are not the big wind resource. The wind resource runs right up to the Midwest and the Great Lakes. So this is actually what California produced in terms of electricity in just last year. So there's a fair amount of electricity that came out of the sun. If you add the sun, the wind, and the hydroelectricity that is output, it equals the amount of natural gas that we burn. Now, California wants to change that. But we've also got nuclear, consider that clean. Coal, there is 1%, we are not burning that in California. The city of Los Angeles is buying that from Utah. California gets charged for it because that's where they're buying it from. And the imported electricity is basically electricity that flows back and forth across the grid lines. So if you look at the natural gas consumption and the renewable production, they're about equivalent in the state of California. By the way, before I got up here, I looked at the actual production today, and we would be 100% solar powered at this moment if it were not for the batteries that we're now storing energy in. So 85% of our electricity that's being produced is coming from renewable sources. That includes the hydroelectric that's being produced. If you factor in the nuclear as well, we're only about 5% right now that is carbon dioxide producing, right now in the middle of the day. But when all this goes away, when the sun goes down, that's when the natural gas fires up. So 2/3 of the day, we're burning a whole lot of natural gas. The state moved from petroleum to natural gas probably about 25 years ago. So that's that. But this is where they want to go. So this is our hope for the future, right? This is to see a completely carbon-free grid. In order to get 67% of our electricity out of the sun, because remember I said California is not a windy state. We're not going to get it from wind. You're going to get it from the sun. So the governor's plan is 67% is going to come from the sun. It means a whole lot more solar farms. How are you going to get that energy produced in the middle of the day into our homes in the evening when you need it? Because that's what you got to solve. If you look at wind, it's gone up to about 15%. That is an increase in wind. I don't know where they're going to put those wind turbines. It's all done by private enterprise, so it's going to be incentives and getting companies to do what the state actually wants to accomplish. If you look at the offshore wind, there are plans to have offshore wind farms off California. There's a whole lot of engineering that has to get solved there for that to happen. They've already solved the problem of how do you get energy produced 25 miles offshore in the water on the land. They've already solved that problem. But California's got really deep waters off our coast, not like the East Coast. So these turbines are going to have to be floating up there. So the 2 farms that have been leased so far, one's off the coast of Morro Bay. It'll be so far over the horizon, you're not going to see it. And the same thing off Humboldt County. But they have to onshore that electricity somehow. So we're going to have to work that part out. But that is a big plan in the state. They intend to get more geothermal, and I suspect a lot of that is being driven by the lithium production, because lithium comes up in that brine with geothermal. And so they're now building the first geothermal lithium production plant in California. It's hit a few snags along the way. We'll see how that goes. But ultimately, you have to have batteries. So that's what this is about. How do you turn the sun into a dispatchable resource so we can have electricity in our homes when we need it? That comes from these big giant batteries that you've got here. That is a battery facility located in Palm Springs. It's just up north of Dillon Road up in Palm Springs. That is only 400 megawatts, but that 400 megawatts is specifically located next to the major substation that switches that power directly into Los Angeles when they need it. So that's the whole point of that. And then finally, just to show what we actually do across the state, this is the nerd chart. This is the one that the scientist in me had to put together. So this is just one particular day from midnight to midnight, showing every 5 minutes, where did the electricity come from? And so you can see pretty clearly in the middle of the day, the sun came up and we had a whole lot of solar energy in the grid. Most people don't know that, but this is all live public data. And the batteries down here, this is the key thing. If you didn't have those batteries, you wouldn't have grid reliability. If you're going to be predominantly powered by renewable sources, you're going to have batteries in order to apply it. So that's about what I got for that. That's the future in California. Hopefully they get there.
Yeah. So what's happening at ski areas? I'm going to be really quick and read something. The skiers are using wind power. They're using solar energy. They're using geothermal energy. There's electrification of snow fleets and heavy equipment, electric vehicles and charging infrastructure, advanced snowmaking technology. There's even some possibilities of hydrogen-powered vehicles at ski areas. So those are some of the major things that ski areas are doing. But this is what really excites me, because everything we've been talking about is existing technology that we're trying to make the most of. But what about hydrogen fuel, where you actually fuel your vehicles and the output is a water droplet? Small modular nuclear reactors, nuclear waste recycling, battery powered by nuclear waste, sawdust-based battery storage, space-based solar power. They collect by a satellite in orbit because there's so much sunlight up there, and then beam it down to Earth. Direct air carbon capture, carbon storage via mineralization and underground injection, solar powered CO2 to fuel reactors, AI enabled fusion energy control, eco-friendly concrete with enhanced strength, microbial conversion of methane. We're going to put you out of business because we're going to get rid of all the methane. And CO2 into useful materials, corporate scale carbon capture investments, and blockchain-based carbon tracking systems. I did a word cloud out of all these articles I have been capturing about the technology that we're moving into. So this is my hope, that technology will be the driver for us to combat what our past technology has created. And in so doing, there's hope. But hope is a verb. So how can the Far West Ski Association members take action? Support sustainable ski areas and businesses generally. Make good decisions with your pocketbook where you decide to spend your money. Advocate for state, federal clean energy policies. And if you don't like what they're doing, then run for office and you make those decisions yourself. Reduce your personal carbon footprints and volunteer for environmental initiatives. This is all part of our action plan with the Environment Committee. And that now brings us to the part where you get to ask the questions. I think we've got just 5 minutes left, but we could extend a little bit further if you wanted to. I'd like to thank all of our panelists. And if you have a question that you'd like to ask a specific panelist, we are happy to do that. Maybe a good question for Curtis. Are there regulations now that require
the long-term management of a.
Yeah, absolutely. There's a program called Financial Assurance where the companies that are in the oil and gas business are drilling new wells. Have to post a bond to cover the cost of restoration for that facility. Now, again, that doesn't cover the legacy assets that are out there today, but for any new activity across the country, and it varies state by state because of states' rights, but absolutely a program. Same on the forestry side. There's, areas that are being logged. There's a reforestation plan. But the key there is, being able to maintain that over the long term. So the good news is we are getting better, right, at this. And how do we continue, like Dave said, then to support those initiatives, those politicians and those businesses that are sitting towards it.
And on the wind side, from about 1995 on, they have had all those things in their contracts by law. They're not allowed to start a project without having a way to take it down. The early days, they didn't have that, and we did have a lot of derelict turbines, but I'm happy to say that I watched a number of derelict turbines come down in the very recent history, about 3 years ago, and was happy to learn that the scrapper that took everything down was able to write a check back to the landowner because there was excess value that they got out of that. So it was actually economically advantageous to remove the old ones. But generally speaking, they don't repurpose the existing foundations because they're going bigger and better, more reliable. So they pretty much have to abandon them, dig them up, take them out, and put in new ones because the old foundations don't support the big new machines.
Yes, a question back there.
Discuss and having quality about the technology present, but problem with storage of that within such a reactive model. Where do you come decades with the infrastructure for?
Tom?
I'm going to talk just a little bit. The problem with hydrogen, hydrogen is a great thing. Storing hydrogen in bottles, compressed hydrogen is actually fairly safe and pretty reliable. The problem is transportation. Because unlike natural gas, which you can put in a pipeline and you can keep the molecule in the pipe fairly well, or at least to some extent, you really cannot do that with hydrogen. It's just, the molecule is just too small. You cannot make a leak-free pipeline. We did host the Iroquois pipeline people. They came down from the Northeast. They came to our tour and they told us that, well, we're not going to be in the pipeline business the rest of our life. I talked with the CEO about the hydrogen pipeline and said the same thing. We just shook our head. Yeah, the molecule is too small. You can bottle it, you can keep it at bottle. Green hydrogen can be produced off grid from wind, which is something that a lot of people are looking at, but it is still pretty expensive to do that. But it is a way to make green hydrogen.
My answer to that is AI. Yes, and I'm serious. I think we're going to find advances in technologies once we start applying AI learning models towards these things. Ask the question, how can we solve global warming? And it will probably say, get rid of all the humans. But then once you get beyond that, it may come up with other ways for us to address these problems. By the way, there's Erica's on the screen. So if you have any questions for Erica, that's her up there now too. Any other questions?
Question for Erica. It seems to me that the definition of the drought is related to the amount of water that's needed. And since that amount goes up so rapidly over the decades as population increases, doesn't that make it more difficult to understand some of the data you were presenting?
Erica, were you able to hear that?
Yeah, I was. I don't think it makes it more difficult to understand the data that I was presenting because I wasn't presenting information on water supply to people for domestic use or for agricultural use or municipal use or any other use for that matter. What I was presenting was information on more on the physical side of precipitation that is likely to. I was presenting information on the supply side rather than the demand side.
But
Yeah, so the population and those demands relate to more the demand side. So what do people want from precipitation? That's not going to affect snowfall per se.
maybe this goes along with that, but what about the drying up of aquifers or?
That has a great deal to do with what people are doing. So human appropriation of water has a tremendous amount to do with that. Yeah.
Question?
It's my understanding that like growing crops is becoming where you can grow things further north. So in that light, is it gonna be snow, been leading us and be going further north?
You know, Tony might have some latitudinal.
Well, as I mentioned, the big ski areas there is to me is actually, you know, not one whose trend I like because its base is almost at sea level and it's starting to get more rain. It's the combination of latitude and altitude. The rule of thumb is that 1 degree of latitude is equivalent to about 275 feet of altitude. And then the other number to remember is the 1 degree centigrade of temperature is 500 feet of altitude. You know, Mammoth it's 37 degrees latitude, but the top's over 11,000 feet. You know, I think Mammoth is just as good now as it was 50 years ago, and I would be surprised if it degrades hardly at all. Southern California, you know, the altitude of our local skiers here is not what it needs to be. If we had gotten San Gorgonio, you know, we would be in better shape, but we didn't. So, you know, it's a little different situation here in terms of natural snow. I didn't get into snowmaking because during the 50 years when, you know, the number of days with the temperatures appropriate has gone down, but the snowmaking technology over that 50 years has improved so much that, you know, the areas that are really serious about their snowmaking, like Big Bear, are much better now than they were 50 years ago. That doesn't mean that they're not going to have more challenges going forward.
Do we have one more question? Yes.
How much does it, I know there's not an answer. How much does it cost to plug a well?
Sure, that's actually a great question and one we get a lot. And there is a lot of variability, but our general rule of thumb is that anywhere between $60,000 to $160,000. When we first started back in the day, we were plugging wells in Montana for around $30,000. Today, price of materials, availability of crews, what have you, it's right around probably that $115,000 range. But then again, what will happen is because these wells are so unknown and so volatile in terms of their condition, that once in a while you'll run into a well. I think our most expensive well to date is nearly $500,000. And the thing of it is, once you're into it, you're into it. And it's like, you know, once you adopt the well, which we actually do, we become the financially liable party. So we don't get to just walk away and say, I'm sorry, it's just too tough. So you just kind of have to gut it out. But on average, again, we're probably right around that $115,000.
You think they're expensive now, wait until you have to send them to college.
Yeah.
So, want to thank all of our speakers today, Thomas and Curtis and Tony and Erica and Auden for being connected. If technology allows, hopefully this is recorded and we'll get it onto the Far West Ski Association website so that you'd be able to go back and review it or have the PowerPoints there. Remember, this really is a personal decision as to what it is that you can do to either contribute more to an issue or help solve it. So, and let's get you out of here because we got to go over and have that great lunch and some of the awards are going on over there. Thanks.